Hello everyone, this is Kevin Zhao, your finance professor at MTSU. In this video, I'm going to show you the detailed process solving two problems in chapter 14, free cash flow to equity discount models. Let's look at the question. Then this is number 3, question 3 in chapter 4. That's one of end of chapter problems. If you are using the textbook, it's on page 377. So here's how I solve this problem. First of all, I wanted to reinstate the problem in this Excel spreadsheet. The reason why I'm doing this is because I really wanted to know the nature of the problem. When I need to review this problem solving in the future, make sure that I understand the nature of the problem and the steps that I took to solve those problems. So anyway, I spent a couple minutes to retype the questions in this Excel spreadsheet, and some of you may take pictures, but either way, you wanted to have basic information ready in this Excel spreadsheet for your future usage. Okay, let's read the question first. Ecolab, that is a cleaning maintenance company, sells chemical systems for cleaning, sanitizing, and maintenance. It reported earnings per share of $2.35 in 1993. That's year 0, and the expected earning growth of 15.5% a year from 1994 to 1998. So this will be a typical two-stage model that you are going to use in this free cash flow to the equity model. So 5-year high growth, 15.5%, and 6% a year after that. That is a constant growth rate during the second stage. The capital expenditure per share was $2.25. Okay, that's the capital expenditure. Depreciation was $1.125 per share in 1993. The difference would be the net capital expenditure. Both were expected to grow at the same rate as earnings from 1994 to 1998, which is also equal to 15.5% a year. Working capital was expected to remain at 5% of revenues. So that gives you a way to estimating working capital needs based on revenue. The revenue was $1 billion in 1993 and were expected to increase 6% a year from 1994 to 1998. So that's high growth time period, and 4% a year after that. That is constant growth time period. The company has a debt ratio of 5%, which is debt divided by debt plus equity. That's 5%. But the plan to finance future investment needs, including working capital investments, using a debt ratio of 20%. So in the future, the debt ratio will change to 20%. So in the past, that's 5%, but in the future, you might use this 20%. The stock was expected to have a beta 1 period of analysis. So once you have beta, risk-free rate, ERP, then you can estimate the cost of equity. The treasury bond rate was 6.5%. There was 63 million shares outstanding, and the market risk premium was 5.5%. Okay, you have 3 questions to answer. First one, A. Assuming that a capital expenditure and depreciation offset each other after 1998. So that's net capital expenditure equals 0 during the constant growth time period. So then you needed to estimate the value per share. Question B. Assuming capital expenditure continued to be 200% depreciation even after 1998, estimate value per share. C. What would the value per share have been if the firm has continued to finance new investments with the old financing mix of 5% debt ratio? Okay, you need to solve 3 problems here with different assumptions. Let's start with answering question A. Question A, estimate the value of the stock per share based on information that you get. Okay, this is Very typical problem that you're going to solve in your second exam using financial models such as FCFE, FCFF, or other methods to estimate share of the price of the share. So I would like to first of all develop a table, a man table. This is the man table I'm going to develop to solve a stock price valuation in a two-stage model. And here source of cash is FCFE. So FCFE is something that I needed to estimate. For the next 5 years, I have 5-year high growth time period. Here's the high growth time period. And the 6th year is the beginning year of the constant growth time period. So I have first stage and the second stage. The 1993 is year 0, and we have basic information here: net income, capital expenditure, depreciation, as well as revenue. I can calculate the working capital in 1993. That is 5% of 1 billion. That is 15 million US dollars. But what I need is not a working capital number, but the change in working capital or change in working capital per share, because calculations here are all per share base. Okay, let's recall how do we get this FCFE. FCFE equals net income minus capital expenditure plus depreciation, which the difference between capital expenditure and depreciation is the net capital expenditure. Then minus change in working capital, and plus change in debt. So here, the change in debt depends upon change in debt. Let me add this one. Change in debt. Change in debt. Okay. Change in debt depends on debt ratio as well as the reinvestment needs. So if company has 5% mix of debt, then change in debt would be 5% times the capital expenditure and the investment in working capital as well. So that is change in debt. Okay, I think this would be a very good structure for you to estimate stock price in this two-stage free cash flow to equity model. Alright, so let's start with 1994 to 1998. This is a high growth time period, and I would like to add a cell here which adds the growth rate here, and 15.5% a year during the first 5 years, and 6% for constant growth time period. So that is a growth rate for earnings, for capital expenditure and depreciation. And so I can do calculation. The net income in 1994 equals the net income in 1993 times 1 plus the growth rate. Right. So, and then you can copy this cell to the end. Look good. So let's double check, make sure each cell is correct. So here you have the estimates of growth rate, estimate of net income based on its growth rate. And for capital expenditure as well as depreciation, it's the same. So you can copy this cell to the right. Wait. Let's fix the row. column. Yeah, the row. Okay, that would be great. And you copy this all the way down to the bottom. Then you double check to see if those cells are correct. So essentially, you use these growth rates to estimate net income, capital expenditure, and depreciation. Okay, it looks everything is good. Then you look at the revenue. Okay, revenue will grow at a 6% each every year during first 5 years. So revenue would be all the revenue times 6 for the first 5 years, and then 4% in the 6th year. Make it look good. And then working capital would be 5% of revenue. You can copy this cell. The change in working capital is year-to-year change in working capital. In this case, it equals 53 minus 50 for 1994, so on and so forth, and you can copy this. Double check. Okay. Looks good. And you want to add 2 decimal points here. But keep in mind, net income, capital expenditure, depreciation are on per share basis, but this change in working capital is in million US dollars. It's not on per share basis, so I need to do calculation to see what is change in working capital per share. So this is actually 3 million divided by total number of shares of outstanding is in this case total number of shares outstanding is 63 million. Okay, divide change in working capital by 63 million US dollars, and both are in million US dollars. So here you got change in working capital per share. And the debt ratio is set as 5% previously, but in the future it will change to 20%. That ratio was 5%, and in question A, assuming that capital expenditure offset after 1998 as the value per share, okay, and that ratio would be 20%. So the company is gonna finance reinvestment by using debt, and therefore company need to issue more debt, and the change in debt would equal to capital expenditure minus depreciation plus change in working capital, and all times the debt ratio times this debt ratio. That gives you change in debt. Okay. Now you can calculate FCFE. FCFE equals net income minus capital expenditure plus depreciation minus change in working capital per share, and plus the new debt issuance to support the new reinvestment. That gave you FCFE. Estimation. To be precise, I want to leave 3 decimal points. and I can copy this cell to the end to get estimation of free cash flow to equity. And then I can do calculation on present value. To do present value, I need to find cost of equity. And previously, I teach you that okay, you need a small table to develop this cost of equity based on risk-free rate, beta, and equity risk premium. Since all three numbers are available in this question, you don't have to do a table. You simply do an equation. Cost of equity equals 6.5% of risk-free rate, which is treasury bond rate, plus beta equal 1, and equity risk premium of 5.5%. 1 times 5.5% equals 5.5%. That gives you 14% cost of equity. Actually, 12% cost of equity. So this will be the discount rate that you use to discount free cash flow to equity. And I'm going to do present value on this free cash flow to equity, which equals free cash flow to the equity divided by 1 plus the cost of equity and the raised power of number of years. Do the same. I needed to fix the row of number of years. Sorry, I need to fix this cost of equity number. Use $ to fix that cell, so you won't change in your equation. Okay, I got the right number here. Present value is calculated. It's a discounted free cash flow to equity in given years. And for 6 years, you don't. Let me see. You don't need to calculate this. What you need is terminal value. Terminal value equals free cash flow in the 6 year beginning year divided by the difference between cost of equity and the growth rate, right? Cost of equity minus growth rate. What is growth rate in terminal time period? 6%. Earnings will free cash flow. Let's assume it's 6%. I get a terminal value. And the present value of the terminal value equals discounted terminal value 1 plus discount rate raised power of 5. Okay, so this is the present value of terminal value. PV, PV of terminal value. V is terminal value. The value of the second stage, right, based on constant growth model. So the total value of equity would be the sum of those 5 present value plus this terminal value. So the equity, total equity value equals sum of those 5 present values plus terminal value. Right? Did I miss anything? And I think this is on per share basis. Therefore, the $37 36 cents would be the estimate of stock price. Alright, so yeah, this is the basic structure that you need to utilize to solve a very typical two-stage problem. And then here I use free cash flow to equity model, and I think the key issue here is to calculate this free cash flow to equity, or actually you estimate based on different growth rate for different items, and make sure you incorporate everything in this FCFE equation: net income, capital expenditure, depreciation, change in working capital, right? And also pay attention to this debt ratio and the changing debt ratio. Changing debt is one part of this FCFE. Okay, in question A, it states that the capital expenditure depreciation will cancel off. Then what will be the stock price? And here we assume that this depreciation capital expenditure will continue to increase, but here we need to change this assumption. Right? So capital expenditure, depreciation, some of them will be zero, and we still need reinvestment in working capital. I think that's a reasonable assumption here. Changing working capital, yeah, and then changing that would be zero. Actually, yeah, a little over zero, because you need to invest in changing working capital as well. So yeah, a little bit increase in that, and this is the free cash flow estimation. Oh my goodness, it increased to $56. And the question asking if this is a realistic estimation, I would say there's a little problem here. What the problem is this? The problem here is when I calculate this terminal value, I assume 6% growth rate. 6% growth rate. But here, since net reinvestment will be zero, then I think it's unrealistic to expect 6% growth rate. If I make growth rate equal zero, so you will have 12% on denominator to discount this future cash flow, and then discount back, you will have smaller value for TV, and therefore smaller stock price. And I think this is a more realistic solution for question A. And here you wanted to make a little comments. You make a little comments. Say assuming net capital expenditure is zero for terminal period. When I say per terminal, that means constant growth time period. So if this is the case, you will get a smaller TV and smaller stock price as well. And if you have any assumption you wanted to reinstate this very important assumption in your problem solving, so that solves A solution. Now let's do question B. B solution. Okay, I think the difference here is assumption. Let's see. What's the assumption for B? Assuming that capital expenditure continued to be 200% of depreciation after 1998. Okay, here assumption is depreciation changes. Let me copy this to solution B, and then your okay, here's solution B, and here capital expenditure to be 200% of depreciation. And previously depreciation, let's say depreciation increase by 6%. Right? You can still do this number here, but make sure that capital expenditure equals depreciation. That's the assumption. Right? And depreciation will increase to $2.45 in year 1999, and let's capital expenditure would be 200% of this, 2 times depreciation, $4.90, and here you want to change this comment edit comments. Assuming capital expenditure 200% of D&A, depreciation amortization. Okay, in this case, your free cash flow will decline due to your capital expenditure. However, your growth rate will increase reasonably to 6%, and it will give you higher equity value of $37. And here, it's a pretty tricky here, because if you have larger amount of cash flow for your capital expenditure, your future FCFE will decline in the terminal year, right? However, it will be compensated by having a bigger growth rate, which will improve your terminal value. Here, the growth rate is 6%. Is growth rate equals 6% in this case? You can do additional calculation to see what is the realistic growth rate, realistic estimation of the growth rate. Growth rate equals reinvestment rate, equity reinvestment rate. This is equity reinvestment, right? Divided by EBI, divided by net income. That is so-called reinvestment rate. Investment rate is pretty high, nearly 100%, right? Investment rate times ROE. ROE equals net income 5.12 divided by total equity. Do you have total equity number in this case? Is there any number for total equity? Unfortunately, there's no such number. Therefore, we could use 6% growth rate in the question. 6% earnings growth rate. That's reasonable assumption. Okay. But if you have additional information about the equity, then you can estimate expected growth rate based on this equity reinvestment rate. Okay, solution C. Copy this. Paste. Solution C. Let's see what's the assumption for this question C. What would the value per share have been if the company had to continue to finance new investment with its old financing mix of 5% debt ratio? Okay, I think this is pretty easy. You simply change the debt ratio here from 20% to 5%. Right, so here is stock value $33.87. Once again, you wanted to add another comments here, assuming that ratio 5%. So finally, I wanted to make little comments because here I think the problem solving had little drawback. First one is the cost of equity, because this two-stage model we're supposed to have high beta during the high growth time period and the lower beta during the constant growth time period. But here we assume beta all equal 1. That is a 1 potential drawback beta. But since the question stated that beta is 1, that's okay. But in a real case, you really want to pay attention to this. Beta should be different. Beta should be higher during this high growth time period. And the second issue is about this growth rate. Make sure it's consistent with its equity reinvestment. And sometimes, previously you assume that net capital expenditure equals 0. If that is the case, then we would assume that growth rate equals 0, which will lead to lower terminal value and lower stock price as well. But if you assume certain amount of capital expenditure, then you wanted to double check if the growth rate stated in the question is realistic. And here is 6%, but if you have more information, I can estimate growth rate based on equity investment rate and return on equity. But here I don't have equity numbers, therefore I was forced to use the 6% as the growth assumption. And the last issue is about this debt ratio, new debt ratio, and previously that ratio was set as 20%, and the question C as if we assume 5% debt ratio, then the valuation will be different, because changing that will be different. And the last issue is the unit. You need to pay attention to the unit here. A common mistake here is you put all the number here without knowing if those numbers are in dollar or in $1,000,000 or billion US dollars or maybe in percentage. So in your problem solving in the future, if you build any financial Excel spreadsheet, I highly recommend you to specify the units of those numbers. And here I wanted to add, let's say, add comments, solution. All numbers are in US dollar per share, except yeah, 3 columns: revenue, WC, and change in WC, except percentages and working capital, change in working capital. So you will know that this is a stop price. This stop price, not the total equity value, and this is in US dollar per share. Everything is on per share basis. So some people make mistake by mixing up, let's say, per share number versus total number. And here, we need to pay attention to that. The unit, the measure of net income, capital expenditures, and so forth. So that concludes our demonstration video solving problem by using two-stage model in this free cash flow to equity chapter 14. This is question 3. I hope you enjoyed the video, and I really want you to pay a lot of attention to the details when you fix each and every problems, and those problems are obviously great opportunity to achieve excellency for your future financial analysis. And I hope you enjoyed this video. I'm going to see you in the next one.